Hi, today we're going to talk about some linear regression and do some coding. So this is collaboratory. We're opening it up to do some Python. So we're going to start with some raw data given to us from our lovely professor. And this is the raw data from GitHub. What we're going to do, we're going to copy this and we're going to go get and perfect. All right, first step is done. So now what we're going to do, just to get it into the system, well, first we're going to need to we're going to do import NP as NP. So now we're going to put in the data, and we're going to have it do NP load test. And we're going to put in the water vapor pressure, which is what we just got, if I can spell, without CSV. And end that, and then we're going to go delimiter is equal to that. Alright. Alright, so that means that if we do this, we should show us all of the data that we just got. So now what we're going to do, we are going to put in what T is, and that is the data, the first column, and then the X value is, well, it's not the X value. We're going to do log of P because that's the vapor pressure. And we're going to do log 10 of data. We're going to go comma 1. Alright, looking good, looking good. Now we're going to go back up here. We're going to make a subplot. So we are going to from plotly dot subplots import make subplots, and then we are also going to put in, import, if I can spell, plotly.io as PIO, and then we are going to do. Alright, so now we can do our eyes a favor, and we are going to pio.template.default is equal to plotly dark. Alright. Oh, what did I forget? Alright, so what we're going to do now is we are going to do the figure. I'm just going to set the parameters by doing make subplot, and that just gives us rows is equal to 1, columns is equal to 1, and just that. And then now we will do, alright, and then now we do figure dot add underscore scatter, and then parentheses, we've got our x is equal to t, which from what we did earlier, comma, our y is going to be equal to log of p, and then this is where we do the mode. Let's do markers, and then name. For now, we are just going to do data. Alright. Found it. Is that what it was? I swear. Yep. Okay. Got an equal sign. Alright. So that's a little bit spread out. So what we're going to do now is we are going to do fig dot config dot update layout, and we're going to go height of 600 with 800. Shift enter. Alright, that's a little bit better. Alright, so if you were to put in a nice curve in here, we want to start minimizing the distance between the actual point and the my best fit. So the way we're going to work on this is that we're going to put in def SSE and of the vector, and here we're going to do A, B, C as the vector, and then we are going to insert the, what's it called? Antoine's equation. Alright, so with this we're going to put in return the np.sum of, we're going to put in our log of p minus new parentheses a minus b, just the b divided by t plus c, and then end that one, and then we're going to end dash, and all of it needs to be squared. Alright, let's make sure that that's right. Yeah, looks like it. Shift enter. Alright. So here we're going to work on a matrix. We're going to create a design matrix. So what we're going to do, so I can explain it, we're going to open up OneNote so I can show you what I'm talking about. Oh wow, that's from engineering design last year. Haha. Alright, let's do a new section. Alright. So bear with me because the handwriting will be a little bit off because I am trying to write with a mouse. So what we're going to do is we are going to write down our Antoine's equation, which is our log of p is equal to a minus b over our temperature plus c. And so our SSE is summation. Whoop. Okay, so from this we are going to try to get t log by itself, and so we are going to do our t plus c log of p, ooh, my handwriting, well, mouse writing technically, a times t plus c minus b. Alright, and that's what I have to do to get it to give me more space. There we go. Alright, sorry, I just got a text message from my mother. Alright, so from this we're going to take out the c. So if you multiply this out, you're going to have t log of p plus c log of p. So if you just subtract the c, we're going to get t log of p. We're going to have our a of t, at, and we're going to have plus c log of p plus a c minus b. So when you look at this right here, this is a constant. I'm going to go C-O-N-S-T as to show constant. So this is constantly changing because we have log of P. The pressure is going to be changing because pressure is reliant on temperature, and the temperature is always changing. So these are only variables, so we can actually combine this into, we're going to do a value of D. So let me scroll this down a little bit more. This is kind of a tedious part. Okay, so let's erase those lines now. Okay, so then that gives us our t log of p is equal to a t plus c log p, and we're going to do plus d. So basically that means that later we'll have our b is equal to ac minus d. ACDC. Well, there's no C at the end, but that's just what my brain thought of. All right, so what we're going to do from here, do I want to make a new section for this? Yeah, I'm just going to do a new section. So from this, we're going to think about our matrix. So we're going to go here. We'll have our temperatures in the first slot. And then we're going to do our dots, and this is T of n. That is a rough looking T. All right, so in the second column, this is going to be our log of P1, and then it'll be negative log P2, negative log P3, and then dot, 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 negative log of, of P of n. That does not look like it. Okay, and over here, we'll just do that. Woo! All right, and this is going to be multiplied by our A, C. I almost wrote B there just because A, B, C. 1, 2, 3. All right, A, C, and D. So that is not a multiplication sign. There we go. All right, so this is the matrix of our values. From this is equivalent. All right, this is equal to our T1 log of P1, and this is how it'll go. Oh, my handwriting's just getting worse as it goes. All right, and then dot 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 T log of P of n. All right, so from that, let me get some more space down here. All right, so from this, because we know our x of t, and we know this, if we get the vector, we can fill it out, and that'll be shown in future me going through the programming tricks. And so we're going to do x is equal to numpy c underscore and here t with a negative log of p, and then we're going to add in those ones. And this just makes sure that it goes down all the way up the row values that t goes. All right. So what did I miss? I forgot the S. I'm really good at forgetting S's. All right, there we go. Okay. All right, so from that, we are going to make my life a little bit easier, and we are going to copy that and paste it here and just adjust it for our needs. So x is equal to t, that's fine. Y, we're going to, instead of log p, we are going to put in our a linear minus, and go b linear minus c linear divided by, and that's going to be our t, well, I need parentheses there, and that's going to be our t, wait, no, I'm wrong, divided by, now this is where we, plus c linear. All right, so that's all the y value. Instead of markers, we're going to do lines. And then instead of data, let's do our Antoine Lynn. All right, just enter. Okay, so that gives us a nice line. So now what we're going to do though, because theoretically whenever we get this final graph, we should be able to calculate for any pressure. So you see right here that this is a straight line. I mean, it's less obvious with some of the closer points, but right here you can really tell that that's a straight line. We don't necessarily want a straight line here. So what we're going to do is right here, let's add a code right here. We are going to make sure that it's curved. So with this, we're going to go create a t-plot, and that's numpy, linspace, and we're going to do the minimum for t, and then the maximum for t. And then with that, we are going to do about, let's do 100 points. So this just makes sure that, what did I miss? Oh, I put 2 E's. All right. There we go. Okay. So that gives us more x values so that it will be less of a line. I added a W. So that means that we need to change all of these t's to t-plot. Plot. I think it's just those two. All right, shift enter. All right, well, so if you see here, it'll have 2 different lines. You can kind of see where this one's more curved, and then the red, which is our original, is straight. So in order to get rid of that red one, we're going to do restart and run all, so it gets rid of that. And then once it gets down here, there we go. So now we have our nice curve. So this has been a discussion of linear regression as well as coding it into Google Colaboratory. Thank you so much for watching. All right, well, so if you see here, it'll have 2 different lines. You can kind of see where this one's more curved, and then the red, which is our original, is straight. So in order to get rid of that red one, we're going to do restart and run all, so it gets rid of that. And once it gets down here, there we go. So now we have our nice curve. So this has been a discussion of linear regression as well as coding it into Google Colaboratory. Thank you so much for watching.